What's up guys, Papa Sean here, and you are looking at an Impulse 14-channel stereo console by Pacific Research and Engineering, circa probably 2000. I say probably because of the Harris branding, and Harris Broadcast bought PR&E in October of 1999. In 2014, Harris split into two companies. The software and networking side became Imagine Communications, and the broadcast equipment side of it became Gates Air, which included PR&E consoles. Then in 2017, they sold off the PR&E division to Wheatstone, and that's your quick history lesson for today. So if you're one of the few people left who still supports this model of console, you may find yourself in the same situation I'm in. You see, PR&E, in their infinite wisdom, decided to use LEDs on all their switches, except for the fader on-off and talkback buttons, where they chose to use incandescent bulbs. And if you've ever had to sit there trying to replace those tiny little bulbs in the lamp holders, you know what a pain it is. Every time I need to order replacements, they're harder to find and more expensive when I do. The most frustrating thing is when you finally get time to replace all the burnt bulbs and you come back a few days later to discover that more have burnt out. So I thought, why can't we just replace these with LEDs? Well, that's why we're here today. Problem is, the 5-volt circuits that the bulbs are on don't have any current limiting resistor on them. The filament in the bulb is essentially just a resistor that glows, so if you try to put in an LED, you'll have way too much current and you'll burn out your LED before very long. That's not a deal breaker here though, because PR&E made it fairly simple to remedy, at least for the fader switches. The talkback is a little different, but I'll show you how to get around those ones too. And I don't even need to get into Kirchhoff's law or voltage drops or anything like that, because PR&E already did the math for us. So in this video, I'll be taking out the old incandescent bulbs, removing the fader modules, and modifying them and putting LEDs in the lamp holders. I'll even go over the schematics and explain why it all works, and show you where you can find the LEDs to complete the project. So the first thing we're going to do is take out one of these fader modules. Each module contains 2 channels, so there's 2 pots on each fader board. We'll remove these pots first with a tiny little hex head screwdriver. We'll just loosen them off a little bit first. Of course, take the knobs off the pots and pull the lamp holders out of the sockets. Sometimes you'll get a stubborn one. I'll get to that one in a minute. Now we pop the hood and reveal the fader module with the 2 pots on each module. Carefully remove the ribbon cable from the main board. Now that we've got the 4 hex screws out of the front, the pot should just pull straight up and away from the module. As you can see, the pins just go through these holes and connect on the other side. Now we'll switch to a small Phillips bit and loosen off the screws mounting the fader board. You may need a socket driver on the standoff or a small pair of pliers. This is for the, I think they call it coffee shield or something like that. I consider it a crumb catcher. It's a sheet of plastic that covers all these modules. So if somebody spills something on the top of the board, it falls through the fader slots and it'll get caught by this sheet of plastic instead of landing on the main board. So this should come out now. Ta-da! Sometimes if the board isn't seated perfectly straight, it'll put a little stress on the edges. Now we'll take the screws the rest of the way out. This is actually my spare console. I have 3 others in use, and I have a spare that lets me work in the shop instead of tying up the studio where people may need to work. Fader module pops out just like that. The next step is to go over to the bench and remove the incandescent bulbs from the lamp holders and replace them with the LEDs. Now, when it comes to putting the LEDs in your lamp holders, what I recommend is at least labeling the bottom with a T so you know which way to mount them in the board. I've marked both top and bottom and positive and negative on the sides to help keep the anodes and cathodes straight when installing them. It's very important that you get the polarity right, or you could burn out your LED trying to send too much reverse current through it. First thing I like to do is cut the legs to length, especially if I'm doing a batch. If I was doing all of these, I'd trim all the legs at once. I found that 14mm works pretty good. So you just figure out where your cathode is. That's the larger of the two, and put that on the negative side and bend the leads back. After you've done a few dozen of these, you'll get the hang of it and it should go much faster. Put the end of the leg through the guide on the side of the lamp holder and pinch it with your needle nose. There we go. Your LED is now mounted. You can put your lens cover on, and when you're ready to install them in the board, you have your marking on the bottom to let you know which way is up. Here are the schematics for the module, dated September 24th, 1999. They call it a dual-channel board. It's a 2-channel fader module board. These are the LEDs, and down here you can see the 2 incandescents. You have channel 1 over here and channel 2 over here, and they're identical. So over here you can see there's a plus 5-volt DC rail supplying all the lights, and over here on the ground side they all go up and through a 150 ohm resistor pack, RN5. But if you look at the incandescent bulbs, they have a jumper shorting the resistor. So these points labeled R4 and R5, which is R6 and R7 on channel 2, show a resistor labeled TBD. That's actually where this trace is shorting the circuit. So you just need to cut the trace here, and your current will then be redirected through the resistor pack. I suppose if you don't want the LEDs to be as bright, you can add a higher value resistor across it and cut the trace to RN5, but we're not doing that today. Here you can see, just as in the schematics, this is how the board would be oriented when installed. On this side, you can see the silkscreen of R4 and R5, and down here is R6 and R7. And if we look at the other side, you can see the trace connecting these 2 pads. So if we eliminate these traces, you'll see the resistance goes from 0 ohms up to 150 ohms. Here's R4, 0 ohms, R5, 0 ohms, R6, 0, and R7, again, 0 ohms. Now, using a fresh, sharp blade, cut these traces without cutting any other ones by mistake, and measure across them. Bingo! 150 ohms resistance. I'll do the 2 on the other channel now. To be very careful not to force it, because if you slip, it could cut across extra traces that you don't want to have to repair. That's also why I measure after cutting to make sure it's a good cut. 150, 150. Hooray! First try. This fader module is now ready to take LED lamps in the on-off switches. Now, when you're looking for LEDs that'll fit, you can go to DigiKey. I'm on the Canadian site, but I don't know which country you're in, so I won't paste any links at the bottom or anything like that. Just go to your local DigiKey site and search for Inolux. That's INOLUX. And then filter by size. You want 3mm T1. You can also add filters for active and through hole if you need to. For my site, I end up with 7 results: red, amber, yellow, yellow-green, green, blue, and white. They are dirt cheap. The price varies between colors, from 50 to 64 cents each, but the price comes down drastically when you buy in volume. For example, when you buy 100 of these ones, it drops to around 17 cents each, so $17 for a pack of 100. In fact, if you buy 100 of each of the 7 colors, it works out to $126.89, which is only 18 cents each at the time of this recording. Totally worth it when you consider each console has 29 bulbs to be replaced. And when you're done, they'll have 139 LEDs in each console. Now we're going to reinstall the fader module. We'll just start the screws, not tightening them all the way. As we saw earlier, if the boards aren't perfectly aligned, your buttons may pinch. Once your lamp holders are installed, you can tighten down the screws. Next is to reinstall the pots. Just put the slider through the slit in the chassis and push the pins through the holes in the module that I showed you earlier. Then you can switch back to your hex head bit. This one you pretty much have to do upside down because when you push the screws in, you'll be pushing the pot back out of the connector on the module. If you're wondering about me, I'll let you know that my background is in computer electronics technology, and I look after 3 radio stations for a living. Plug this back in now. And that's how you do the fader modules. The talkback button, on the other hand, is a completely different animal. There's the talkback button, which is another incandescent, but it's not connected to a fader board. It's just connected to a small PCB with the switch and a ribbon cable connector that goes to J42 on the main board. So it's a little bit more difficult, but I'll show you how it can be done. Now we're going to remove the talkback switch. We'll get this one out of the way so we can see a little better. As you can see, this is just a passive component with no active electronics on it, just a switch with 4 contacts and a 6-pin ribbon cable connector. So for the talkback switch, it's a very simple little PCB here. It's just the switch, positive and negative for the light, which is connected to pins 2 and 3. And the talkback circuit, which connects to pins 1 and 4. Pins 5 and 6 are not used. So all we need to do is put a current limiting resistor across the negative connector and pin 2 on the J1 connector. Not because it has to be on the negative side, because it doesn't. It can be on either the positive or negative side. But we're going to use the negative for 2 reasons. First, every other LED in this console has the resistor on the negative side of the circuit, so we might as well stay consistent. And secondly, because we have a nice, clear, open path between our 2 solder points. If we use the positive side, we need to run the resistor around the other pins to get to pin 3, which increases the chance of a short. So we'll take our 150 ohm resistor and measure it to make sure it's within spec. And that's close enough for me. Make sure our tip is nice and tinned. We'll add just a little bit of solder onto our 2 pins to make sure we have something to grab onto. As you can see, if we measure across the negative terminal and pin 2, we'll get 0 ohms. And we'll just tack that leg down. And then do the other one. Add just a touch more solder. Now, if you want to confirm that it's a good soldering job, we can measure across the resistor and it should be shorted because of the trace on the board. We'll trim the legs back and then carefully cut the trace between the 2 pins, and the resistor can take over. We'll measure again, and it should show approximately 150 ohms. 147.8, that works. So 1 little resistor across those 2 points, cut the trace that connects them, and now you have 150 ohms. I usually like to leave a little space under the resistor just to better dissipate the heat. Not that it will be an issue here with the low-powered circuit, but I consider it best practice. Now we can reinstall it in the board and put in our lamp holder, and we're all done. We'll remount the switch in the chassis. Again, I'll just get the screws started here before I tighten them down. lamp holder back in. Reconnect our ribbon cables. And finish tightening the screws. And here we have the finished product. I decided to use green for the talkback button just to be different. Anyway, that's it for this video. Thanks for watching. Hope it was helpful. And we'll see you on the next one. Bye for now.